Hello guys, welcome back to the channel. My name is Chisom, your coding companion, and today we'll be moving into the wonderful world of React. Now, if you're a developer like me that's in love with React, or someone that wants to really go into React, or someone that has had problem with React before now and maybe just wants to kick up that passion for React again, I suggest you really watch this video and watch it till the end. In this video, I'll be talking about React hooks and the most important ones you require to be a React developer in 2024. Stay tuned. Okay, welcome back. So before I start anything on this particular topic, I just want to give a brief overview of React and kind of like compare it to vanilla JS, as plain JavaScript, as we've known it right from time. Now, let's go. React is a popular JavaScript library for building user interfaces, and this presentation obviously will cover the key concepts and features of React. Firstly, let's go. Virtual DOM, components, and state management. Now, let me just give a general overview before going here. Very important. The major difference between React and vanilla JS, of which React is actually under vanilla JS because it's still up just JavaScript, is that while plain vanilla JS is imperative in its styling, code style, React follows a rather declarative approach. Let me explain what I mean. In vanilla JS, you do stuff like DOM manipulation. And in this kind of, in that concept, what you do is you as a developer, you are actually holding full control of everything. Meaning that if, for example, you want the text on this in a particular HTML node to change at certain points in time, you have to manually change it. You hook in as the normal process. You query the DOM for that particular element. Maybe you want to change the text. You do use a text content or an inner text. Maybe you want to change the HTML, use an inner HTML. Or maybe you want to attach an event listener to it, maybe an on-click event. You do all this manually. That's why plain JavaScript is imperative. Now, React is declarative in the sense that what React does is it tells you to provide how you want the application to look like, and then provide the flow in which the application should go, and it handles all those stuff like DOM manipulation and everything, updates, state, and so on and so forth under the hood. So in React, you are more or less declaring how you want your UI, your user interface to be, and you're allowing React to take control over everything. So that's the major difference. And this particular difference can actually assist in optimizing your development time, your development speed, and a lot of things within your application itself. Yeah, because first of all, one of the major pitfalls of using plain JavaScript is that you could end up writing spaghetti code. Maybe you have a particular event that does a lot of DOM manipulations. You manipulate this node, and the other node, and before you know it, you start banging your head on the wall trying to discover what particular line is doing this or what particular line is doing that. And especially if it's a code base you worked on like 3 or 4, 5 months ago, you have to take some time for you to really understand what's actually going on. But with React, you can be able to manage your code base much more efficiently and effectively. So without wasting any time, let me just go to the concept you see on my screen. First is virtual DOM. Now, the virtual DOM is more or less like a copy of the DOM. Is what React uses to update the DOM and does a lot of things. For the sake of this video, I just want to keep this short, so I won't really go deep into it. But if you would like me to make more videos on certain concept in React in depth, just make sure you indicate in the comment section below. Okay, so let's continue. Components. Now, React works with a component architecture, meaning what it does is that it splits your UI, your user interface, into components. So rather than thinking of your entire user interface as a whole. You are rather thinking of them as different component parts that work together in a specific way. So this particular idea is actually very effective and very efficient when you're working in, when you're building front-end applications. And then state management, I will explain what state is soon. Let's just go to the next slide. So the next slide here, we have component lifecycle. Now, the beauty that React has brought here is that it has created this kind of separation of concerns of different aspects of your application. For instance, if you're working on a plain vanilla JavaScript application, you are handling everything from the beginning to, like I said, it's imperative. You are handling your component lifecycle from when it's actually mounted, when something changes within it, and when it is unmounted, maybe if you switch from that page to another page or something like that. Now, all that you are doing, that all those things are happening. You are the one controlling all those things, and it can be quite messy. But that's React actually gives us certain features that enable us to effectively manage our component lifecycle from the moment it enters the DOM, the moment it populates the UI, to the moment it's actually leaving the UI. So that's just what component lifecycle means in a nutshell. Like the entire lifecycle of your component from its creation to its deletion. Then we go to state and props. Now, state and props are two very important concepts in React, and they define how your UI is going to look like. Now, props are the easiest difference I can give between the two of them is that props are static. Props are like static values that you don't expect to change unless, you don't expect to change. While states are more or less reactive values, that is, values that you know that they're going to be changing throughout your app. So if you know that something is not changing, so it's actually a prop. If it's changing, then it's state. Let me give an example. Let's say you create a component, maybe a section component, and all your sections are actually looking very similar. Now, you can decide to pass a prop called title for each instance of the components you create. Maybe your hero section, you pass in a prop title of hero, but it's identical to the next section. Maybe your next section is your contact section or your testimonial section. And now, because you know that that title for each section is static, you can pass it as a prop. But for example, if you have an application like maybe a counter application, and this particular counter application is keeping track of the number of times a user clicks on a particular button or item on the page. Now, obviously, it's not going to be a static value. It's going to change depending on what the user does. So that those kind of things that are reactive, those kind of things that change, are what we call state. So that's for state. Let's go to the next slide, and we have React hooks, which is actually the main topic of today. Now, React hooks is a powerful addition to the library that allows functional components to access state and lifecycle features. Now, in case you might be confused about what functional components mean, now in React, like I said, React works on a component-based architecture, meaning it actually splits your UI into little bits. That is what we call components. Now, there are two types of components in React. We have class-based components and functional components. Now, class-based components, if you are familiar with JavaScript classes, use the class syntax. Now, class-based components were the original way in which components were written in React before functional components came into existence. And in the early days of functional components, they didn't have access to all these lifecycle methods, like when your component mounts and when your component is updated, when it is on mounting, and so on and so forth. But class components had those. But then from, I think, React version 16, if I'm correct, you can correct me down in the comment section if you feel I'm wrong, but then I can check it later on. React hooks were added in order to hook into these life cycle features and a bunch of other things. And needless to say, it's only available. These React hooks are only available in functional components. And I don't really see the need of class components anymore. Basically, everything that a class component can do, a functional component does it, and much more. It does in a much more cleaner way. So generically, I don't think any of you will be using class-based components, but you can feel free to use whatever you like to do. And so that's just it for the introduction to React. And we'll go straight to what we have next. So basically, I just created a basic project that will enable me explain all these hooks that you're expected to learn. And I pulled this project I scaffolded this project using Vite. So Vite is an awesome build tool. The alternate would be create React app, or if you're using frameworks like Next, to be create Next app. But I prefer using Vite for my regular React projects because it has a lot of beautiful advantages. And just like the name implies, Vite, fast, is really fast, really, really fast. Trust me on that. So there's basically nothing much here. In my source, I just have my app.tsx, just the div that renders the logos that have links, and then h1, and then a button that renders count. Now we go to our first hook, the useState hook. Now, useState hook, as name implies, is used to hook into states. That is, you use it to create states. That is values that are actually changing in your application. For instance, in this particular counter application, let me just go here. You see that the moment I click on this button, every time I click on this button, the count is updated. Now, I achieve this using state, and it's very, very simple to do. We start with const this. Then let's say I want to destructure, maybe the name of my state is count. It could be anything. It could be theme. It could be maybe play, set play, whatever. But right now it's count. I'm working on my application, so I have count and set count. And I will explain what these guys mean in a few moments. So useState 0. Now, what this is doing is I'm destructuring two particular things from my useState hook, and the first one is count. Count is the variable that is the actual count. It is the variable that is storing the actual count in the application. While set count is a setter function that helps you update the count. So depending on what the user, maybe a particular action that the user takes, you can update the count using this. So we are destructuring this straight from the useState hook. That's just it. It's very simple to utilize it. And once you've done this, you can easily just add, put this wherever you want. Maybe like here now, you see that I'm updating the count using this set count, and so on and so forth. That's just it for the state hook. I want to go next to the next hook, and that's the useEffect. Now, useEffect is a hook that helps you hook into, allow me to use that term, hook into component lifecycle, meaning it allows you to define what will happen when your component is mounted, when state updates, or when your component is unmounted. So it's very, very simple to declare. All you have to do is just say useEffect and import that from React. And now useEffect takes two parameters. The first is a function. So function. Yeah, I'm using an extension, React ESC snippets. I would link that to the description in case you want to use it. Just so I don't have to stress myself typing all this every single time. So like I said, it takes two parameters. One is a function, and the second parameter is an array. Now I'm going to explain what this actually does. Now, the function is what will be called each time your useEffect runs. Now, that's what this particular function parameter does. While this second one that is taking an array is just, it's where you indicate your dependencies. What do I mean by dependencies? What I mean is what the useEffect will look at before running the piece of code in the anonymous function, in the function you pass within it. Now, there are three states. Let me put it this way. There are three states when you're using your useEffect. There are three types of scenarios. First one is you want this particular piece of code, this particular function, to run only when the component has been mounted. That is when it has entered the DOM. The second case is you want it to run every single time, whether it was mounted or maybe a state changed. And then the third case, when you only want it to run when state changes. So those three cases, we're going to treat that. Now, the first case is when you only want it to run when the component is mounted. So if you want that to happen, just pass in an empty dependency array. Now, this thing is simply telling my application, let me just restart the application. So once I reload, look at the console, you see that, sorry, it's running 2 times because I'm in strict mode. Let me just disable that for the purpose of this video. But usually you won't want to disable strict mode because it helps you catch bugs. React put it for a reason. So now that I've disabled strict mode, let me go back and we expect the normal behavior. So if I refresh the page, you see in the console it loaded, it ran, React is awesome. And now this particular thing is nothing is going to happen again, even after I update my account. That's because I specified within my useEffect that I only want this to render when I mount. I didn't specify that I want it to render when a particular state changes. Now, let's say I actually want this thing to render both on mount and when this particular state changes. All I have to do is indicate the state I want it to look out for within the dependency array. And now, if I really hit save quickly and I go to my application and I reload, you'll notice something. First, as it mounted, see React is awesome. And now, each time I click the button, you see that React is awesome is logged to the console. So what I've told my useEffect hook right now is that each time count updates, that is when I want this particular piece of code that I specified here to run. Now, obviously, there's also another case where you actually want the effect to run every single time your component is rendered. The next hook I would like to talk about is the useRef hook. Now, the useRef hook has 2 major use cases. And the first use case would be, so let's just first import this. It's very, very simple. So the first is very easy to, you're not destructuring anything in the useRef hook naturally. So let's just say I want to create a counter ref and just say useRef, and I just want to set the initial to null. Now I'm using TypeScript, and since I'm working with a counter, I obviously want it to be a number. So let's just say number or null, so that TypeScript will want me later on. So what this is because I'm using TypeScript. If I was using plain JavaScript, I won't need to put this. But what this is simply telling TypeScript is that I'm either accepting a number or a null as the values coming into this ref. Okay, so let's continue very, very quickly. Now, I said the ref has 2 major use cases. The first is to keep track of the values of variables between renders. Now, excuse me, ref persists values between renders, meaning if I had used, let's say I use a normal variable, maybe a variable like test, and I initialize to a particular value, and I change that value when the state updated. Now, whenever the component is re-rendered, I lose my reference to the new value because I have re-rendered. But with ref persists values to render. So let's say, for example, I want my ref to keep track of my count. So let's say I want to keep track of the previous values of my count each time I update my count. So this is what I'm going to do. So counter ref dot current. Now the ref, I forgot to mention this. Now the ref isn't just like a value that is returned. The ref is actually an object, and it takes this particular shape. The ref is an object that just contains a current property, and what's contained inside this current is whatever you passed in. For example, now in this place I initialize the counter ref. What's currently in this current is null. So this is basically the shape of your counter ref at the moment I created initialized it. Yeah, that's the term. So let's continue. So counter ref dot current, and I want this to be equal to my count. So what this is doing is that each time I want to update the count, it will first store the original count in the counterref current object or current property before updating the count. Let's see how it is in the application. So let's go. I reload. Now you see that in the console, you see the count is initialized to 0 while the counterref is null. So now every time I update my count, now watch. Update my count. You see that my count is 1, my new count is 1, but the previous count is 0. I click again. My new count is 2, previous count is 1. I click again. And what I'm doing is I'm keeping track of values, and these values are persisting through renders. I said that there is a second use case, and the second use case is to keep track of DOM node. Let's say I want to keep track of maybe this H1, and let's say I just want to log the value of this H1 every time my count changes. I can use ref for that. Just say ref, not reference, ref. So I have my passing to the ref prop, and this is going to be H1 ref. And I have something like this. So H1 ref. I want it to be that anytime the count change, I also want to log the text content of the H1 ref. So H1 ref dot current dot text content. TypeScript is going to warn me right now. It's possibly null. So I'm just going to use optional chaining. And then text content does not occur in never. That's because this is, so this, I need to update my types. This should be null or react node. Excuse me, react node. So yeah, that should do the trick. That should do the trick. For some insane reason doesn't work. Oh, sorry, no, not react node. That should be a HTML header element. Sorry, let's just HTML heading element. I think it's heading element, more or less. The types can be, you can check out the types. So now if I update my count, you see that here, vit and react. Update count, vit plus react, and that's actually the value of the H. Just move straightforward to the next hook, which is the useReducer hook. Now, I think I'll just talk about this one rather than just indicating it more or less, because this video is really getting too long. The useReducer hook is used to manage complex state logic. Let's say, for example, you are creating a screen recording application and you actually want to keep track of complex states, like when you press the play button, something should happen, and maybe other than think, okay, when you press the stop button, it's going to stop the video, save it, and do a bunch of other things at the background. Now, using ordinary state for those kind of complex situations might be tedious and might even give you headaches in the long run. But if you use useReducer, you are able to manage your state more efficiently. I think I'll just show you the syntax of how reducers work. So you are still destructuring state, so it still works as state. So it's basically still updating state, but in a different way. So it works in this way. This, I can spell this part well. Equals useReducer. And now useReducer takes 3 parameters, 2 compulsory, 1 optional. The first parameter it takes is the reducer. Now the reducer is a function that actually handles the complex state logic, which whenever you dispatch actions, it will update the states. And then the next one is the initial argument. Now the initial argument is what you want your initial value of state to be. Like, for example, you're in this regular count state, and initialize the count state to 0. So the initial argument here was 0. And then the final one, which is an optional parameter, is your initialization function. It is simply a function that returns the initial value of the state. You don't have to indicate it, but there are some cases where you would want to indicate it. But most cases you don't really need it. That's why it's optional, and you just have this. If you want me to make a video on useReducer, please indicate in the comment section below. But this all I'll be saying on useReducer. And then another one again would be useContext. Now, useContext is more or less it's a state, where I call it a state management beef that React gave into a system, something like that. Now, context allows you to share values between parent component and child components, no matter how deeply nested that particular child component is. Just imagine this. Let's say I have maybe my app component, and my app component has different sections: my home, my hero, my about. Or okay, so let's say I have an app, then I have a wrapper, then I have an about, then I have within the about I have an article. Within the article, this doesn't really make sense, but just follow me. Within the article, then I have some kind of variable, maybe a theme, maybe a button, yeah, and that button is what changes the theme for the entire application. Now, what happens is that I can either do this in using state management libraries, or I can prop drill, meaning I pass in props from the parent component to the child component, or I could easily opt in for context. Now, context allows me to pass information from the parent, so it passes context, like the name implies, from the parent component to the grandchild, child, great grandchild, name it, whatever, no matter how many levels deep, just by simply creating the context, then wrapping the components in a context provider, and then using the context within whatever function you want to use. Let's go to the next and final ones, which really I believe they're not really compulsory, but knowing them will actually help a lot in making you really write efficient and scalable React applications. And those hooks are useCallback and useMemo. Now, useCallback and useMemo are performance optimization hooks, in the sense that they actually help you upgrade the performance of your site. So what it does is that two of them, they each memoize different items. But when I say memoize, I mean caching. You cache so that instead of your components or your application to maybe re-render something that might make your app lag, maybe some sort of expensive calculation or something of the sort, you actually prevent that. So I'll just write them down. So useMemo is used to memoize or cache objects. Like it's used to memorize a particular value. useMemo is very similar to useEffect. useMemo and useCallback are similar to useEffect in the sense that they also take in dependency arrays. So if, for example, I'm just saying maybe const memoized count, which normally you won't actually do this because count doesn't need to be memoized. Memoized count equals useMemo, and I have an anonymous function. What all this is doing is that it's returning count. Like I said, this is actually not ideal, but I just want to show you how the thing is going to be written. And something like this. So maybe you want to return the count after maybe count updates. This is unnecessary because count is going to be updated every render. But you might have they're definitely going to be use cases for this particular thing. Now you see that it returned a value. So useMemo returns a value while its counterpart useCallback. So let me just change that to useCallback. useCallback, callback size count. Okay, let's just call this callback. I forgot callback. And what useCallback does is like it returns a function. So it's like you are memoizing, you are caching a function, and you're still passing it. So a dependency array. Let's just say, for example, you want to return maybe just creating a random function here. Want a function that logs testing callback to the excuse me, function that logs this to the console. Now you see that the difference between useMemo and useCallback, that useMemo return the value, a cached, a memoized value, but useCallback is returning a function. So that's just basically it. Okay, that's a wrap for this video. That's a wrap for this coding session. If you really enjoyed this video, don't forget to give it a thumbs up, subscribe, and ring that notification bell to never miss out on any of our coding escapades. I also love to hear opinions about this video, and if you have any video requests, I'll be happy to hear them. Please indicate them in the comment section, or you can reach out to me privately. Happy coding and stay awesome.